Hi guys, today what we're going to talk about is the atomic number, the mass number, and charge of an atom. Now, previously what we were talking about is how within the history of science we came to find out about these three particles. Okay, we talked specifically about how the first one that we found was the electron. Okay, the electron was found in that cathode ray experiment where they were shooting those electrons, okay, a beam of light across that cathode ray tube, and we found out, that it was negatively charged. Then, in the gold foil experiment, we found that we had this nucleus. Well, at that time, they thought it was just a proton. Okay, since then, in an experiment that we didn't talk about, they found out that there is actually neutrons as well. Real briefly, kind of about that experiment, is they were weighing different atoms against other atoms, and they knew that, like hydrogen, for example, had a certain weight. And so what they thought should happen was that two hydrogens, because hydrogen has one proton, well, that should weigh the exact same as a helium atom, because helium had two protons. But there was this kind of mismatch, and it actually took 4 hydrogen atoms to weigh the same as one helium atom. Well, they came to find out, and they came to, think that there's something else inside the nucleus of the atom. And that's kind of where we got this idea of the neutron. And since then, obviously, we've proved that that's also correct. So, regardless, we have these 3 subatomic particles. Okay, and these are what, really talks about, and these are the ones that, really clarify for us the different characteristics of an atom. So, real briefly, okay, the electron, so this first one right here, this is the symbol that we're going to use. You're going to see it a lot, so make sure every time you see this E with the negative sign, you realize that that's an electron. Okay, it has a charge of -1, and then it has a mass of 0 AMUs. Okay, and what an AMU is it's an atomic mass unit. Let's see if I can write it real small there. AMU. And that's for all of them. There we go. Okay. Now, and, oh, good, it is going to stay with it. So, it has a mass of 0 AMUs. And that's just because they weigh so little, it wouldn't make sense to say 0.0000000000 all the way to kind of what it is. So, regardless, we just use this, it's a different scale. Kind of like pounds is different than grams. Well, atomic mass units, or AMU, is different. The electron weighs 0. Next one that we have is the proton. Okay, proton has the symbol P with a plus sign. It has a charge of +1, and it's going to weigh 1 AMU, or 1 atomic mass unit. And then the last one, okay, this last subatomic particle is the neutron. It's going to have an N with a 0 to indicate that it's neutral. Its charge is 0, and it is also 1 AMU. Now, what we're going to talk about today is 3 different things and how they tell us the number of electrons, protons, and neutrons inside an atom. All right, so let's put this back up over here, and let's talk about the 3 things that we're going to talk about. So they are the atomic number. Okay, the atomic number has this symbol, sometimes we use Z, and it is the number of protons in the nucleus of each atom of a given element. Okay, on the periodic table, the atomic number is the number of a particular atom, okay, or of a particular element. So hydrogen is atomic number 1. Okay, that means that it has 1 proton. Every single atom of hydrogen in the world will have exactly 1 proton. That's what that means. Okay, the second one is the mass number. Okay, the mass number is the total number of protons and neutrons in the nucleus of a given atom. Okay, and this is something that can change per atom, from one thing to the other. And we're going to talk about isotopes a little later, and that's, kind of gets into that more. But for now, just the mass number, we always add up the number of protons and neutrons in the nucleus of the atom. Okay, and then the last thing we're going to talk about, and it's going to be a little bit after, we're talking about today, but then it's going to be a little while before we talk about this again, but that is the charge. And that's just the difference between the protons that an atom has and the electrons that an atom has. And so we're just going to kind of compare those 2 things. All right, so again, let's put those back over here, and we'll kind of come back and talk to them as we go. Now, for a given element, okay, or specifically a given atom, we're going to have these three things. And these are kind of the three main characteristics that we're going to look at for each atom. And this is how we kind of write it. Okay, now the X is for the element symbol. So if we're talking about hydrogen, you know, an H would go right here instead of the X. Okay, if we're talking about lithium, it'd be an Li. You know, whatever the symbol is from the periodic table. So let's kind of put this out of the way, and I will show you how all these things go. All right, make it a little bit smaller. Okay, so keep that close so that we can talk about it. Now, let's look at an example specifically. So if we have, let's say, what's a good one? Li, 3, and let's put a 7 up here. And let's, for now, let's leave this area blank, and I'll kind of explain what that means. So when we're looking at all this, okay, this is going to tell us the number of protons, the number of neutrons, and the number of electrons that this example has. Now, the first one and the easiest one is going to be the atomic number. So, atomic number, remember this guy up here, it is the number of protons that are in the nucleus, okay? And they're always in the nucleus for a given element. Now, the atomic number is always written down here in this bottom left-hand corner. Okay, so the atomic number is down here. For our example up here, it's right here. Since the atomic number is 3, the number of protons is 3. Pretty simple, okay? The next one is the mass number. Now, the mass number is the total number of protons plus neutrons in the nucleus of the atom. So the mass number is on our symbol. Okay, you can see it kind of, I'm circling it in the red dot. It's right here in this upper left-hand corner. For our example, it's a 7. Now, what that means is that protons plus neutrons has to equal 7. So, kind of put it out here. That has to equal 7. Now, pretty simple math, right? 3 plus what is going to equal 7? In this case, it is 4. Okay? Not too bad, right? You can see that 3 plus 4, that equals 7. Our mass number is 7. We're good to go. Now, our last example here is our charge. Okay? Notice the charge is in the upper right-hand corner. Here, I left it blank. Okay? And just kind of show you that it can go here, it doesn't necessarily have to, is I put these dotted lines. Now, because there's nothing here, what we assume is that it is a 0. That means that there are the exact same number of protons and electrons in our sample. Okay? Which means that if there is 3 protons, then we would have 3 electrons. Okay, and so we can figure out the number of protons, neutrons, and electrons from our chemical symbol right here. Okay, let's go ahead and move that guy a little bit, and we're going to try another example. All right. Whoa, there are different pieces here. All right, so we got there. Make this guy smaller too. Oh, he doesn't want to move. A little big. Alright, tell you what, we're just going to get rid of him. There we go. We'll just write in 3. There we go. Okay, so. Alright, so if we try another example, we can see that it's going to be written a different way. Alright, so for this example, let's say that we have, let's use our example of, here we go, bromine 80. Now, this is a slightly different example only because it's written like this and not quite like this. That's okay. This is kind of where we can go from this. All right, so if we're looking for protons, neutrons, and electrons, so protons, neutrons, and electrons. So we got that there. Well, what we can know is that this number right here, that is the mass number. So this number 80 is going to be the protons plus neutrons. So just to help remind us, that's going to equal 80. When we have it written like this, okay, we're going to have to assume that the protons and the electrons are exactly the same because it doesn't tell us anything about charge. And lastly, so where we have to start though is our protons for every single thing. So this one's no exception. Now, bromine, this one's kind of tricky. Guys, I'm going to have you actually think about your periodic tables and kind of look at a periodic table. I don't have one with me right here. Actually, I can show you right here. Okay, so here is our periodic table. I'm going to zoom in on bromine so that you can see it. Okay, bromine is right here. Okay, and you can kind of see, it's backwards, but that is number 35. Okay, so that's going to be our atomic number. All right, bromine, number 35. Well, the atomic number is the number of protons that are in the nucleus. So that means our atomic number there is 35. And remember how I said earlier, because this doesn't say anything about a charge, if there's nothing about a charge, or if this charge up here is left blank, we have to assume that it is exactly the same as our protons. So in this case, also 35. And then lastly, if we're looking at neutrons, remember the atomic mass, or the mass number, is right here after the dash, or it's going to be up here in this upper left-hand corner, and that it's going to be equal to 80. Now, atomic mass is protons plus neutrons, so 35 plus what equals 80. In this case, 35 plus 45 is equal to 80, so now we have protons, neutrons, and electrons for a second example. Okay guys, we're going to spend a lot of time on this in the near future, practicing, figuring out these different characteristics of atoms, protons, neutrons, and electrons. See you next time.